Alright, so for problem 7, you really need to be able to organize your thoughts in a really effective way. And I'm just going to show you that process, and I'm going to let you figure out how to solve this. Now, keep in mind the rules of this scheme that they have with this ice cream. So what we have here is Abby. There's Abby. Now I'll label Abby as A. Let me get a pen up. Okay, so Abby would be A, and then let's call friend 1 and friend 2. So what you need to do is you need to think about all the different outcomes that are possible. There are only a finite number of outcomes, and each outcome has the same probability of occurring. So when I say an outcome, or also they may refer to this as an event in your book, it's each possible 3 coin flip. Each person has a coin, and they each flip a coin, and they can either get heads or tails. And if you read the rules, it explains it in the problem. But Abby, what it comes down to, and what we're trying to figure out is what is the probability that Abby does not pay for her own ice cream cone. And so I'll just write it down here. Probability that A does not pay does not pay for, I guess, A's ice cream cone. So the only way that this is going to happen, the only way that Abby is going to pay for her own ice cream cone is if she flips. So Abby goes. So 3 friends devise a scheme. Each person flips 1 coin, and someone whose coin is different from the other pays for all 3 ice cream cones. So Abby would have to does not pay. What you could do is you can figure out, and it may or may not be easier for you to think about, is this is also 1 minus the probability that she does pay for ice cream cone. A pays for A's cone. So the only way that Abby will pay for her own cone is if she flips a so just one example, and you can organize all the different possibilities here. So let's just imagine tails, heads, heads. She's paying. So this is her paying, and so you could make another column if you want over here. And this is the outcome column, and this is if she's paying or not, and you can figure this out. So she is paying. So she pays for all 3, but all we care about is if she's at least paying for her own ice cream cone. So yeah, she is paying for her own ice cream cone because she flips a tails and the other people flipped heads. So based upon the rules of this, she's paying for her ice cream cone and others, but we care about only hers, at least hers. So another possibility is if they all flip the same outcome. And just an example of this is tails, tails, tails. She's paying here. An example of where she's not paying, and the only circumstance where she is not paying is if she flipped the same as one of the other people. So let's just say tails, tails, heads. F2 is paying for everyone's ice cream cone, and that's the only way that Abby, will not pay for her own ice cream cone is if F1 or F2, friend 1 or friend 2, is paying for all of them. So we're looking for when Abby flips the same coin, same heads or tails as only one other person. The other friend flips a different coin. So she's not paying. And so there's only a certain amount of outcomes that are possible. And the best way, in my opinion, of figuring out all the different outcomes is think about alphabetical order. Now, I didn't do this, but let's just imagine I'm starting this over again. I'll use green this time. So let's just imagine that, so the first one in the alphabetical order would be H, H, H. And then it would be H, H, T. And then it would be H, and then it would move this to a tails, and then the next would be heads. And then it would be heads, tails, tails. And there would only be a certain amount of outcomes, and you'll eventually get to the point where you get all the way to the bottom. And you'll have tails, tails, tails. And then what you'll do is you'll figure out each of the outcomes, and you'll figure out all the outcomes that are not. And I probably shouldn't have mentioned this right here. This is probably, you just go directly for this, the probability that does not. So you're counting up all the nots and dividing by the total amount that you figured out of the different outcomes. So that's the way I would approach it. I think this is a pretty simple way, and hopefully this helps. So let me know if you have any other concerns about this problem.